Okay, for today, we are first going to start off with bell work. You're going to need your Chromebooks open so that you can get to your calculator, and you're going to need a pencil. If those two things haven't happened yet, please make them happen now. For bell work for Monday, it says find each missing length to the nearest tenth. When we look at the example, we have to first determine, are we finding a leg or a hypotenuse? On this one, the right angle is right here. And so remember, any side that touches a right angle is a leg. Therefore, we are finding a leg, and 15 is C, my hypotenuse. So we'll do 12 squared plus B squared equals 15 squared. You're going to use your calculator to figure out what 12 squared is, and that should be 144 plus B squared. We don't know what B is, so we're going to leave it a variable. And then 15 squared should be 225. Your whole goal is to get B by itself. So you will plug into, or you'll have to get rid of the items that are with B. So when I look, the things that are with B are 144. So I'll go minus 144, and whatever you do to one side, you do to the other. I'm left with B squared on the left, and on the right, 225 minus 144 is 81. B is still not by itself, so we have to say to ourselves, what's the opposite of squared? And that's square root. So that gets rid of the 2. And then again, whatever you do to one side, you do to the other. And B equals 9. So your job now is going to be to solve 1, 2, and 3. Please make sure then that you put your answers on the right. You'll have about 6 minutes. Go ahead and pause this video. At this time, I'd like for you to close your Chromebooks. We will not need them for this part of the lesson. You're going to be getting a worksheet that I'd like for you to fill out as we go over today's lesson of identifying and creating translations on the coordinate plane. After the video and we fill out the worksheet, there will be a big ideas assignment, and the goal is to get a 80% or higher on it.
Math shorts. Translation describes one way a geometric shape can move on a coordinate plane. When you translate a shape, it's like you make an exact copy of it and slide the copy to another spot. The shape stays the same. Here's how it works. Say we want to move this triangle to another location on a coordinate plane. First, we name the ordered pair for each of the shape's vertices. Then, to show where the shape is moving, we can use a mapping notation, like this, to show the translation. If we move positive 4 on the x-axis, then we know to move the shape 4 to the right. And if we use negative 2 on the y-axis, then we know to move the shape 2 down on the coordinate plane. Now we know which direction to slide the shape. Notice that the moved shape is congruent to the original, which means their corresponding angles and sides are the same. We use these little symbols to show what we've done to create this translation. So there you have it. When a geometric shape is moved on a coordinate plane, it's called translation.
So for your first blank, a transformation changes a figure into another figure. The new figure is called the image, and a translation is the one that we're doing today. And we talked about this in our introduction on our last class, that the SL in translation also matches the movement that it does, SL in slides. The main thing to keep in mind is it's not going to turn, but in it is going to be every point is going to be the same distance and the same direction from where it started. So with it being same distance and same direction, it should also be the same exact size. So it does not change size at all.
We'll start this lesson off by watching a skateboard sliding along the pavement. Much like Jennifer on her skateboard, a translation is a slide from one location to another. A translation is not a change in size, and a translation is not a change in orientation. When translating a point P with coordinates x, y, we can use the capital T notation. Our point P with coordinates x, y is translated to the new point P prime. Notice that the A and B values correspond with the x and y coordinates of the point P as it's translated to P prime. By applying these values, we can find the coordinates of the image P prime. Let's start our first example by performing the following transformation on line segment PQ. We can start by writing down the coordinates of the endpoints of PQ with P at 3, 0 and Q at 6, negative 6. Now, since this line segment is being translated, we know that P prime and Q prime will have different coordinates than P and Q. Since our first value is a negative 8, we'll subtract 8 from both x values. And remember that the x-axis is horizontal, so negative 8 for x means moving to the left 8 spaces. Our second value, positive 4, corresponds with the y values, so we will add 4 to each y value. And that is the same thing as going up 4 units. And now that we have our path laid down, we can look at the graph and visualize that line segment PQ being translated to its new location at P prime, Q prime. Finally, we can verify our final coordinates by finding the first x value, 3 minus 8, is negative 5. 0 plus 4 is just positive 4. And now for Q prime, 6 minus 8 is equal to negative 2. And the final coordinate, negative 6 plus 4, is equal to negative 2. Notice that these points correspond with our graph for the image of line segment P prime, Q prime. Now we can visualize and conceptualize just what it means for a line segment to be translated by sliding it from one location on the coordinate plane to another. For our last example, we are going to construct the image of triangle E prime, F prime, G prime after the following transformation. We'll start off by writing down the coordinates of the vertices of triangle E, F, G. To find the coordinates of E prime, F prime, and G prime, we'll start by applying the values of the translation. The x value is 6, so we're going to add 6 to all of the x values in each coordinate. Positive 6 calls for us to slide 6 units to the right horizontally along the x-axis. Next is the y value of negative 1. We are going to subtract 1 from all of the y coordinates. On the graph, negative 1 means to move down vertically 1 unit along the y-axis. Now to verify the coordinates of E prime, F prime, and G prime. We start by adding 6 to each x coordinate, and that'll give us the new x coordinate of E prime, F prime, and G prime. We'll do the same thing with the y coordinates by subtracting 1 from each to get those new y coordinates. Now we can look at the graph and visualize the original image being translated to the right 6 units and down 1 to its new location at E prime, F prime, G prime. And we can see that our points, E prime at negative 2, negative 2, F prime at positive 6, positive 1, and G prime at 3, negative 9, all correspond. And we can take one last look at that figure, taking a slide across the coordinate plane. Some quick final words on translation. A translation is when a point or image changes location without changing size or direction. We know that the notation for translation requires applying the a value to the x-coordinate and the b value to the y-coordinate. Just like a skateboarder, a translation is a slide from one location to another.
Okay, so for our first, we're just going to be very simple. We have to say either yes or no that the blue figure is translation of the red figure. So A, red's original, right? And so as we slide, we get the blue. So yes, it slides. B, red's the original, and then we look at the blue. That would be no, it rotates. Okay, would you please try the next two on your own? You should have said the first one was no, it's changing size. And if you remember, so we can just put changes size. This is one of our transformations. It's called dilation. And then from red to blue, no, it flips. Do you remember which one means flips? You should have said reflection. Okay, try 3 and 4. On number 3, you should have said yes. It slides. It's the same shape. It's the same size. And it didn't turn. And then on number 4, you should have said no, changes size. Graph the image of the figure using the transformation given 5 units right and 1 unit up. So we have B, G, and T. It's going to be important. We've never had to graph figures on the coordinate plane before. We've had to graph lines, but not figures. You are going to have to put the letters when you do your translation. So step 1 is, there's a couple ways to do this. You can write the ordered pair. So we'll do G, T, and B. G is going to be 1, 2, negative 3. And then you're going down 1, so it's negative 1. T is going to be negative 1, and you go down 1. And then B is going to be negative 3, and you're going down 1, 2, 3, 4, 5, so negative 5. Now, what we want to do is we want to go 5 units right and 1 unit up. Okay? Right, just remember this is your left, this is your right. If we move right on a number line, this is going to be plus 5. And if we move up, this is going to be plus 1. So we can add 5 to all of our x values. Now, in the video, he said that word prime. That's that little apostrophe icon. That's what we put on the new image. So don't put GTB. You have to put the little prime symbol to show that something happened to it. So we would go negative 3 plus 5 is positive 2. Negative 1 plus 5 is positive 4. And negative 3 plus 5 is 2. And so I just did this part right here. Now I'm going to go 1 unit up. That's my y. So -1 plus 1 is 0. -1 plus 1 is 0. -5 plus 1 is -4. Now it's going to be our job to go graph these. So I'm going to go over 2, and I'm going to stay on the axis for my g prime. Then I'm going to go over 4, again, staying on my x-axis because you're going up 0, and t prime. Then b, you'll go over 2, and you're going to go down 4. B prime. And then we'll just draw in our figure. And one thing I can do is I can count. I went from this G to G prime. I went up 1, so good. And I went over 1, 2, 3, 4, 5. You don't have to draw that purple line. I'm just checking my work to see that I actually did this. Okay, let's go on to the next one. Graph the image of the figure using the transformation given. 1 unit left and 2 units up. So again, we're going to do our 3 points. We're going to find the ordered pairs. So y, I'm going left 3, so it's -3, and we didn't move off the axis, so that's 0. M, I went left 3, so -3, and we went down 1, 2, 3, 4, so that's -4. And then for G, I didn't move at all, left or right, so that's 0. And then I went down 2, so it's -2. For my translated sides, y prime, m prime, and g prime, that's that little apostrophe mark, 1 unit left. So if we're going left on a number line, that is we're going negative side. Okay, and then 2 units up, going up is positive. So for my left, my 1 unit left, that's the x values. So -3 minus 1 is -4. -3 minus 1 is -4. And 0 minus 1 is -1. For my zeros, we're going 2 units up. So 0 plus 2 is 2. -4 plus 2 is -2. And then -2 plus 2 is 0. So I will go graph. -4 means I go left 4, up 2. There's my y prime. For m, we're going to go -4. We're going to go down 2. So that will be right here, m prime. And then for g, -1, and 0 means I don't move off the axis. So that'll be right here is g. It's okay that these figures are overlapping. It didn't move enough to avoid overlapping, so that doesn't make you wrong. Then I would just test between 2 points. Remember, they have to be the same letter. So I would go from m to m prime, or y to y prime, or g to g prime. So I'm just going to do m to m prime. And I went left 1, which was good. And then I went 1, 2. I went up 2. And it looks exactly the same size, and it's the same shape. Let's do our next one. This one, we're writing a rule to describe each transformation. So units up and down, right? Up and down would be my y value, and then units left and right would be my x value. The nice part is you only have to go from one letter to the next prime. You don't have to test every point. So for this, I'm just going to move from my L's. Okay, so units up and down. Remember, your original figure is the one that does not have a prime. So will I be starting on the black or the blue? I'll be starting on the black. So that's down. How do we show down in math? Negative. 1, 2, 3. It kind of might remind you of slope a little bit. Your answer is just not a fraction. So I went down 3. And then units left or right, well, I'm moving to the right 1. So that's the translation that is happening. We're moving 3 down, 1 right. And I could just test that. I'm going 1, 2, 3, down, 1 right. 1, 2, 3, down, 1 right. Why don't you try this one? So you have to think to yourself, which triangle do I have to start with? Am I starting with the blue or am I starting with the black? And then you're going to decide if you're going up or down, and then left or right, and how many. Okay, you should have said that you're starting with the black. I'm just going to go from the T's. You're going up. 1, 2, 3, 4. Oh, I don't know what happened to my line there. And then I'm going 0. I'm not moving left or right. I stayed on this line. So again, 1, 2, 3, 4. Didn't move left or right. 1, 2, 3, 4. I didn't move left or right. Okay, on this one, we don't have a picture. We have to figure out how do we get from one number to the next. So I'm just going to rewrite this so it's a little bit easier. I like writing it up and down. Okay, and I'm trying to figure out how do I get from -3 to -1. We'll visualize a number line. On a number line, if you're going from -3 to -1, because these are my x values, these are my x values, left and right. So if you're starting at -3 and you're going to -1, how do you move that way? You would go +2, and you're moving on a number line to the right. Then your second value is the y value. This is if we're moving up and down that y-axis. So if I start at 3 on the y-axis and I get to 2, am I moving up or down? We're moving down. We're moving down 1. So in case you haven't figured it out, up is positive, down is negative, left is negative, right is positive. It's a little confusing because these are X's and these are Y's, but I wrote it the way that Big Ideas is going to have it. And so Big Ideas does confuse it. It could have been written better, but this is just the way it is on Big Ideas. So I wanted you to be used to seeing it this way. Okay, why don't you try this one? So remember, left and right is your first value. You should have said that you're going right 1, because +1 gets me from 0 to 1. Now try your y value. If you start at 2 and you're going to 1, you have to go down, and it's -1. Right? All right, our last one, a triangle is formed by the coordinates -6, 4, -5, 6, and -4, 4. Find the new coordinates of the triangle after it's moved down 9 units, moved 9 units down and 4 units right. Okay, we're going to give you a second. Go ahead, and I want you to just put the old triangle, and then let's go from there. You're going to be in charge of translating here in just a second, but I want you to put a dot at all 3 of those, and then it'll create a triangle for us. Okay, please double check. You should have the points labeled A, B, C. Now it's going to be our job to find the triangle after it's moved 9 units down. So that would be a -9. And then 4 units right. Again, if you're moving right on a number line, that would be +4. Okay, so I'm going to be using these coordinates here, and I'm going to list the new ones, A prime, B prime, and C prime. Again, this is very important that you have the A prime, B prime, and C prime so that you're showing which one's the old and which one's the new. And then also so we can prove that your triangle didn't rotate at all. So -6 plus 4 would be -2. -5 plus 4 would be -1. And -4 plus 4 would be 0. For 9 units down, so we're subtracting 9. 4 minus 9 is going to give me -5. 6 minus 9 is going to give me -3. And then 4 minus 9 is going to give me -5. So now it's my job to go graph these to prove. So I would go -2, 5 units down is right here. And I'm going to put A prime. Then for B, -1, 3 units down, B prime. And then for C, you're going to stay on the origin, but now you're going to move down 5. C prime. The good news is it does look like it's the same size and it's the same shape. I'm just going to test it. So I'm going to go from 1A to my A prime, and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 down was good. And then 1, 2, 3, 4, right, that one also checks out. It's your time to show what you know. You are completing Big Ideas 2.2. Remember, we will know we have it when we get an 80% or higher on this. And then when you are done, make sure you screenshot your results and put them in Canvas.